Welcome everyone to the Rancho Mirage Library and Observatory. We're going to be getting started in just about 5 minutes, but if you're watching this on the YouTube playback, feel free to jump ahead. That is YouTube playback after the fact. Feel free to jump ahead to the chapter markings as shown in the description below. But for those of us here now, while we're waiting, we've got a little preview for you. Right there is our current live view, and so we'll be back with you in just a few minutes. Welcome everyone to the Rancho Mirage Library and Observatory. Tonight we are again doing a special preview night, and I am here joined by Lauren Zuckerberg, our Observatory Program Coordinator. She is here right beside me and able to address a number of things, and will be helping with a lot of your questions. So welcome, Lauren.
Thank you, Eric. Good evening, everybody. And thank you for joining our Swoon the Moon International Observe the Moon Night preview.
Yes, yeah, we have this very long title here for a good reason. That is because tonight is not International Observe the Moon Night. It is actually this Saturday, and so we are doing a preview for a number of reasons. One of which is, well, there's some scheduling conflicts, it happens. But there are plenty of other reasons for doing this, which we will get into momentarily. But while we're looking up at the night sky tonight, we're going to be able to see quite a bit because we actually have very good clear skies. This is NASA Worldview view of the sky tonight, or rather the sky today. This morning, this is what we were seeing, and it was beautifully clear all day. So this is a great time to be looking up at the night sky. But let's go ahead and take a look at all sorts of things at once with this view here. This view includes we've got our worldview highlight right there, but we also have our small telescope right here showing nearly the full disk of the moon. We have our main telescope upstairs, which you can actually see directly below me, looking up at a highly magnified view of the moon. We'll be exploring around in detail with that. And directly below that is our all-sky camera view. It's highlighted some point sources there, and you can see the bright shining moon directly over the dome as viewed from the all-sky camera. So we are going to be going into a bunch of different things tonight, but again, we're calling this a preview night because, well, there's a lot of different things that go on around this time of year for encouraging people to get out and go look up at the night sky. And one such thing is, the way we've been highlighting it is with a special packet we've been offering for you guys. If you want to get this packet, you can come on by the library, and if you ask at the information desk for that, we can get you one of those packets. A number of you have already come in for these packets. They're a great little resource for all the different things going on this time of the year. We've actually just made it past a couple of those big events. We went through World Space Week, which I'm going to go ahead and highlight this view a bit more. World Space Week is always from the 4th to the 10th. It's just a great time for celebrating space and space exploration. But we also passed Astronomy Day, which International Astronomy Day was last Saturday. But there's 2 of those each year, so you don't have to wait a whole year if you feel like you just missed it. But we also have a lot of useful things in here. Again, this Saturday is International Observe the Moon Night. You get this packet, you can get your certificate of participation for that, but there's a lot of other useful things in here, and we're going to dive into looking at the moon with some of this stuff. The first page here shows some really good highlights, which if you had a keen eye where you were looking a minute ago, you will have seen a different view of the moon to some extent than what is shown on this page, and that is because this page is for International Observe the Moon Night, and you'll see more of the moon is lit up. And that's an important thing we'll come back to later. The nice thing is we can't show you everything that's being highlighted on in this packet because a lot of it's in the darker side of the moon right now, on the night side of the moon. But we will be able to highlight a number of things as we zip through some of these things. We'll be able to come back here in a minute to look at some of the landing sites from the Apollo missions. We'll also be able to talk in detail about a number of the seas. This page is really valuable for figuring out your lunar geography because I'm actually really bad at lunar geography. I'm just going to admit it. There are a lot of seas up there, and it's hard to remember which one's which. Some of them, of course, you'll get down easily, like the Sea of Tranquility, but knowing them and the fact that they have their Latin names and their translated names, yeah, it's worth having a nice map, and this is a great one for looking at that, as well as another page that highlights those seas specifically. We actually have a moon observation journal in here, which is really useful. Again, we'll talk more about how to use that in a few minutes. And we also have a few different sky maps for you to be using that are very, very useful in general. And of course, we have some fun bingo and a nice coloring page at the end there. So there's a lot of fun stuff in there. Highly recommend you guys come on out and check out, or rather, actually just get one of these packets because it'll be really fun to have and utilize for not just this month, but as a means to figure out what's going on with the moon in the sky. All right, so let's go ahead and jump right back to that full view here. And I'm going to give a few worthwhile highlights just by switching to this view here. And turn that off. This is a great view developed by NASA, or a great image. The one, again, just down right, the other side, right there. That image is one generated by NASA's Scientific Visualization Studio. They make a great dial-a-moon thing. In the packet, there's a nice URL if you need help finding that. But this is what the moon looks like right now tonight. And when we're looking up at the moon, it is worth understanding how we get different phases and different views of the moon. If we pull that packet back up, for example, we can scroll down to that second page, which has a nice highlight of different phases. And if we want to actually get an idea of where we're at in that, we are actually heading towards, well, we're past first quarter by just one day. So we are past the marker here. We're past this one, but just barely. So we are actually, I'm going to use a different pointer. Give me that pointer. Give me that pointer. It does not want to give me that pointer. Oh, fine. This pointer will work. We are past this point here. We're actually heading towards a waxing gibbous. We're actually technically in a waxing gibbous moon, but just barely. And we can actually see how this ends up working out by actually comparing a few different views. Let me actually just go ahead and hop back over here so you can see a little bit better. If we want to see a more than full moon, or a more than half full moon, you can think about the perspective that we're dealing with there. Let me actually hit this button here. And if we are on the Earth here and looking towards the moon down this way in a nice, okay, this one doesn't want to do what I want. Everything's fighting me right now. I apologize. All right, so if we're looking back over here, from the Earth at this point, looking towards the moon there, we would actually see more than half of the moon full. And the fun thing about all this different software and such we don't have to rely solely on pictures, static pictures to really show this for us. We can actually use things like Space Engine over here to get that view. And so this is a nice view of the Earth right now. You can see Europe over on the left, Russia right in frame. And if we pan up in this nice, very zoomed in view, we get the moon rising there. Can queue up 2001: A Space Odyssey if you want that. But as you can see, we are just past a half quarter or first quarter moon, so a half full moon. And if we highlight our orbits here, just to give you an idea on how zoomed in this view is, this is where the camera is actually positioned. So in order to get the moon to appear that big relative to the Earth, you need quite the zoom lens. But if we actually go ahead and advance time at a faster rate, and if I am very careful with things, we can see the Earth spinning beneath us here, and we can see how the phases of the moon begin to progress from this viewpoint. Now you can see that waxing gibbous is really looking right there. And as we go into the actual night of International Observe the Moon Night, you can see this matches the images that are in the pamphlet that we are handing out. Gotta back the camera right back up. And as you can see, the moon gets more and more full as time progresses here from this perspective. But yeah, all right. So always love showing that view off because it's interesting to see everything going there. All right, welcome. All right, so from, again, now that the moon is nearly full from this view, if we swap back over to this highlight, you can see what we are seeing corresponds to that center picture right here. We're looking right over the top of the moon, and you can see quite readily the nearly full moon from there. But that is, of course, not what we're seeing tonight. We are seeing something very different. So let's go ahead and jump back over to our combo view where we can see all this stuff. I do like this highlight here. I did not mean to go all the way there. There it is. So with this setup, we can actually zoom in on some things and actually figure out where, if we're looking specifically at the moon's orbit, we can see in the view that I just highlighted here, the sun is pretty readily set up on here. Welcome, Deb. Yeah, so the sun is, of course, off in this direction here in relative to this image, but we can see also specifically that if we were right at first quarter, the moon would be straight on down this way. Of course, I can't draw a straight line worth anything, but nevertheless, what we can also see with this is that the moon is pretty close to its closest point on the Earth, because if you look at this gray circle that is underneath the actual marked orbit, you can see that the orbit takes the moon from being really close to the Earth to further away up at the top here. Yeah, hopefully it's not too cloudy in the Midwest. I can actually check that. There's some parts over there that are a little cloudy. If you're wondering how I'm checking that, I, of course, still have NASA Worldview here, so we can actually see some clouds over on that side. So there's some clouds out there earlier today. But yeah, hopefully you guys got some clear spots in different spots, and hopefully it ends up clear on actual International Observe the Moon night. Again, this is the preview. So yeah, that is what we've been seeing there. So yeah, over there in Michigan, yeah, you got some clouds over there. So hopefully that clears up for you before Saturday. But yeah. All right. Jumping back over to, we are already there. I wanted to be here. Yeah. So when we're looking at where the moon is now, yes, it is closer than average. Again, with this great view here, we can actually look right at that that line that you see going behind the moon there. That is actually a 2-scale representation of the sun, or the Earth, and the moon and its actual distance. And we can zoom in over on that right side there and see that the moon is just under 30 Earth diameters away from us right now, which puts it quite a ways out there, but it is actually closer than that average point, that 380,000 kilometer number you might have often heard referenced. All right, so, okay, these views are great. I love seeing everything nice and highlighted one way or another, but I also want to look at actual pictures of the moon. So let's go ahead and find somewhere specific we want to go. We will actually go ahead and start on that journey by first going to our small telescope view here. And let's go ahead and adjust that. We can always start somewhere, which is a nice classic site. That is the Sea of Tranquility, which thankfully is very nice and centered in the lit portion of the moon right now. Let's go ahead and adjust the telescope there. So where's the Sea of Tranquility? Well, when you get your packet, you'll have that nice and highlighted, but you can also see right here, this is the Sea of Tranquility right here. That is where we first set foot on the moon, and we did so towards the southern edge of it down in this area here. I will be slightly off because of the different angles and everything throwing me off. But in any case, we can actually swap back over to our mapped view here. Get that really nicely highlighted. There we go. Yeah, see, I was right. there's the Sea of Tranquility, and I said it was down in that area. So there it is. So I wasn't too far off. Like I said, my lunar geography could be better, but still doing okay. So, okay, we want to see this place. Let's go ahead and try and see it closer up. So first things first, let's switch back over here. And from this view, we have in that upper left-hand corner, that is our big telescope view. The moon's wandering in that view, and everything moves in a way that I don't expect it to on my control of that telescope here. So give me a moment. The other thing that is really difficult with this view is that telescope has a derotator on it that always wants to pick the way it wants to rotate the camera to. Unfortunately, that means it's rotated relative to the image to the right of it. The thing we're looking at right now is Mare Crisium, that sea that is to the east of the Sea of Tranquility. That sea right there is what we are looking at in the far left over here. So we are close to the Sea of Tranquility. Let's try and get ourselves a bit closer. All right, going right past that nice bright crater there. And there's our Sea of Tranquility. So I want to go south, which should be this way. Right around here should be pretty good. Yeah. So where we're focused right now with the main telescope is this area right here, which again means we're looking pretty darn close to the Apollo 11 landing site, as highlighted on this image down here. So let's see. Let's go ahead and zoom in with the big telescope here. And yeah, anyone out there, can you see anything on there? You see a Apollo 11 landing site there? I certainly don't. Now, there's a good reason for that. And while you might think that, oh, nice shiny thing on a dark surface of the seas should make it easier to spot, right? Well, first, let's go into why the seas are dark. The seas are the lower lying areas of the surface of the moon. They are what happens where you have a thinner portion of the crust of the moon from various impacts and other things way in the past. And those areas actually filled in with lava quite a long time ago. Though because they filled in with lava, that actually makes that surface younger than the higher regions, the highlands of the moon. So again, where we're looking here, this is the mare, the seas, while these areas with the higher incidence of craters are the highlands. And so since they filled in with the lava, they actually end up being a bit darker because they haven't had the same amount of time, and they also aren't made of the exact same minerals that made up the crust originally. So that is why they are darker. But why doesn't the darker sea help give us some contrast to see the landers and such? Well, there's a good reason for that. And to answer that, let's go ahead and flip back over to this view here. This is a view I always love showing. This red circle you see to my right is a superimposed diameter of the moon over the continental United States. And, well, actually all of North America. It goes to Canada and Mexico as well. But in any case, what you see there is the scale of what we are looking at. So keeping this view in mind, when we are looking here, that full disk there is about the size of the full United States, which makes the Sea of Tranquility on the scale of, well, probably pretty close to some of the larger states. Might be a little smaller than Texas. It's up there, though. And so when we're over here trying to spot something that is literally not much, like it might have trouble fitting in this room, but that's about as far as it is. It might be able to fit on the observatory deck, the main body of it. Yeah, we're not going to be able to spot that because of the scales we're looking at. Again, the magnification we are actually showing on the left, I'd have to check the numbers on that, but I want to say it's on the scale of around 350 times magnification, and so it's just not going to be able to pull out those details. The craters you see in our big telescope view, again, some of these craters that we can spot down here, those are kilometers upon kilometers across. They are not small features. And so to expect to see something that is quite small, and especially to expect to see, say, the American flags that were placed there, again, on the scale of about this big, yeah, we're not going to be able to spot that. So just to set your expectations on International Observe the Moon Night, it's not International actually be able to see the things on the surface of the moon that man put there night. Granted, there are some things that can be spotted from the Earth with special techniques. They're so special that I wouldn't recommend trying to do it yourself. In fact, what are at some of those landing sites are what are called the lunar laser retroreflectors. They are a set of mirrors that actually send light directly back to the source, and those mirrors can be spotted at least when you fire a big bright laser at them. The lasers that are used to actually hit those targets, by the time that, ooh, something just went by the camera. Want to say we might have had a plane fly by the moon there. But the lasers that are actually fired at the moon, ooh, something happened there. Might have to check on that. But seems like we're still on target. Okay. Sometimes things have a mind of their own too. Anyway, the laser retroreflectors, when an observatory is going to utilize those experiments, they need a big, powerful laser, and that laser, when it hits the surface of the moon, will hit a kilometers wide area, and somewhere in there is a little target that has those retroreflectors, and it sends some of the light back. They send a series of pulses that is unique, and in doing that, they can actually measure how long it takes for those pulses to get to the retroreflector and to come back. There are a lot of these. Well, there's a few of these on the moon, if I'm really being clear. There are a few of these on different places on the moon, and they're really useful because they actually allow us to measure how far away the moon is. And so that is one of the most, those really useful things that the missions to the moon have done. If you've ever heard someone quote the statistic that the moon is moving away from us on an average by around 3 centimeters per year, it's because of those retroreflectors that we know that. Again, as we were looking back at different things like this kind of view here, the orbit of the moon is not perfectly circular, and actually it's much clearer over here. It's not perfectly circular, and it actually moves quite a long ways from being close to being far from the Earth. Again, this highlight from around 28 times the diameter of the Earth away to around 32. That is the range at which the moon moves from the Earth in the course of 1 month. But that average, again, is what is increasing by 3 centimeters per year. Yep, and again, that average of around 380,000 kilometers comes out to around 1.3 light seconds away, as our docent Ron has pointed out there in the chat. Yes, that is a great other way to note things. Again, when we say light seconds or light years, we're talking about units of distance. It's the amount of time it takes light to travel those distances. All right, get back over here, and let's actually jump into our packet again. Over at the packet, I blitzed through a number of things in here. We've already noted a few sites. I would love to go and visit every single landing site that we have there. There's a lot of great things to see, but I'll leave that to your future observations to some extent to do. But other things we have to note are, and we did already talk about the seas, we can skip by a few of them, which we will as we go, but we have a section in here, the Moon Observation Journal, and I'm not going to go through and answer each one of those questions. That's, again, for you to do, but I will touch on some of these things. I already have touched on some of these things, so worth spending some time and actually learning on your own for this. And that is one of the reasons why we have this Moon Observation Journal, where you can actually go and fill in these little circles here. And as you fill in these circles, you'll be able to actually show what phase it is from night to night and see how things are changing there, which is very, very useful to do. But as the moon is moving through the sky, it's worth understanding how we will see it change from night to night. Again, if we go back to that nice little phase diagram up here, there it is. In this phase diagram, we can see that the moon is orbiting the Earth, and that causes the phases. But that means the moon is moving relative to a couple of things. It's moving relative to background stars, which will be pretty useful for you to be able to actually go and try and spot on your own. And we can actually see what some of that looks like by actually switching to our solarium view here. Switch that off. There it is. And one thing to note is the moon actually puts out a bit of glare and actually makes it harder to spot some things. But in this view here, which we can again bring up bigger, when we're looking at this particular view, we can see that the moon is hanging out pretty close to Saturn right now. And we can zoom in on it. And the question is, where is the moon going to be tomorrow night? Well, the nice thing is, despite the fact that Saturn and Jupiter are moving with respect to background stars, they're doing so at a much slower rate than the moon, and we can actually go ahead and see, if you were to observe the moon at this exact same time tomorrow, you can see how the moon moves from night to night. This is something that you should do on your own, not just rely on this simulated view to actually do, but still, it's worth seeing. And to highlight it better, let's go ahead and actually turn on a few different things. Let's turn on our constellations. I'll name them, and we'll go ahead and turn on our orbits as well. So that is the orbit of the moon. And if we go to tomorrow, we can see that at this same time tomorrow night, if you were to look at the moon and compare where it was or where it is relative to where we see it right now, best thing again will be to look towards Saturn and Jupiter. If we go to tomorrow, you can see just how far it moved there. It moved all the way over here. Goes from being to the right of Saturn to being right in between Saturn and Jupiter. Again, it's going to be a little bit south of them. But nevertheless, that is a worthwhile thing to actually note. Why? Well, if we actually think about things, again, back over at our, not that view, this view with the packet pulled up. If we're looking specifically at the moon at different times of day, we can actually expect to find it in different parts of the sky based on what phase it is. If we were looking at the full moon, as shown again right in the center there, if we're looking at the full moon, then we can expect the moon to actually rise in our sky right at sunset and end up setting right at sunrise, because it's on the exact opposite side of the Earth from the sun. Likewise, right now we are just past first quarter. Again, we are just past this diagram or this image here. And that means that the moon was very high in the sky right at sunset, which makes this a great time for looking up at the moon. Again, as will be noted in the packet, the reason for International Astronomy Day and International Observe the Moon Night to be about where they are is because the moon will actually be up and visible in the early evening in a good way. If we actually go to the waning phases, which are off on the right side of this image, the moon is up and rises later and later. And in fact, right at last quarter moon, you won't see the moon in the night sky until after midnight. That is when, right at last quarter is around when you would expect the moon to rise at midnight. And if you want to see a waning crescent moon, you better get up early because you're only going to see it in the morning. And likewise, with the two on the ends here, new moon, don't try to see a new moon unless you're going to be looking for a solar eclipse because, well, the moon is going to be too close to the sun and it's going to be essentially impossible to see right at that phase. I believe the record of seeing a waxing crescent moon in its proximity to the new moon is close to around 24 hours after that new moon, somewhere in that time frame, because the moon simply has to get far enough away from the sun to be visible, and you end up with that nice hairline, eyelash, or really thin toenail, as it were, in the sky. Good question, Jane. We are hoping to start doing some stargazing here soon. We are really working to try and actually make things safe. And we are hoping that sometime in the near future, we'll be able to actually have in-person stargazing here on site very, very soon. Not likely before the end of the year, unfortunately, but we hope to be doing it here soon. Excellent question. All right, so let's see. Been looking at these phases here. Went down that whole chain of logic that I wanted to go through, I think. Let's see. Let's jump back over here, make sure we're still enjoying actually looking at the moon here. Swap back over to this view and get over here. Now let's see. All right. So I blitzed through a lot of different information on the moon. If you guys have any specific questions, please let me know. In the meantime, I'm going to go ahead and navigate our main telescope. We are still looking off towards, actually we've drifted off towards the right, looks like the southeast of the Sea of Tranquility. Let's go ahead and make our way to Mare Vaporum, the Sea of Vapors, because that should have some really nice, good detail for us right now. So let's see, it should be off in this direction here, as long as I'm not wandering the wrong direction. Very well could be. There's where we were. There we are. Again, everything being rotated makes this a bit of a challenge, and this particular view feels like it could use a little bit more exposure time. So let's go ahead and actually, I'm just going to turn the gain up. There we go. All right. Let's see. Okay. Yeah. Mare Serenitatis is up on the left there. Yep. And yeah, there we are. Right in the center of that view is Mare Vaporum right here. Again, to give you a specific view, let's go ahead and zoom in on that. There we are. You can see that nice crater right there. It's one that actually has a good central peak, just like these two over here. That central peak is driven by a rebound. These are impact craters. Again, a large object hit the surface of the moon, dug out a big hole, and the actual center of that crater rebounded back up before freezing into place. All right, so Mare Vaporum would be right there, which means if we are looking back at this view here, Mare Vaporum, to the north of Mare Vaporum, we have a nice ridge, which has Apollo 15's landing site just above it there. Let's go ahead and switch back over and see if we can't find our way there. Again, north at the moment is towards the bottom of the frame because of the way this view is rotated. And so if we actually work our way here, right towards the center of the image now would be near where Apollo 15 landed. And again, we just passed the 50th anniversary of that mission. It was the first time that that we took the lunar rover to the moon, and our program coordinator and I had a great conversation about this back at the 50th anniversary. So if you want to check that out, yeah, feel free to check out that live stream. There's a lot of fun stuff to talk about there. But yeah, that landing site, if I have my location right, should be right in this area here. They landed right next to a rille, or rill. It's a collapsed lava tube canyon that's a kilometer across and half a kilometer deep. It is quite a dramatic thing, and they would not have been able to actually get over to it and look at it nicely if they didn't have the lunar rover, because that allowed them to actually do a good amount of, to cover much more distance than any previous mission. All right. And just for the fun of it, I'm going to swap the picture below me to looking up at the top of the dome. Yes, it was Hadley Ryle. Thank you, Ron. All right, so let's see. We swap back over to our map and again see right where we're looking for this, we are looking right about here. And let's go ahead and wander our way up and see if we can't spot Archimedes and, oh, it's hard to spot, Aristellus and Autolycus. Those are always fun things to spot. Actually, yeah, we shouldn't be too far off from them already. Yeah, they're already in frame. A couple of them. Oh, other way. Other way. There it is. Yeah. All right. Now, again, because this is the seas of the moon, there are a lot fewer craters in those regions. And actually, I just want to start wandering about. We keep going northward. Ooh, there's a nice nice linear feature right at the center of the screen there. Yep, there it is. All right, close enough. That line right there will be the result of a number of different possible features, but the straight line features that you see near the seas can actually be, are believed to be attributed to the actual expansion and contraction of the crust from those events. And so with a bit of stretching at that point, you have a section, a fault line basically fall down in the center while the area around it spread out. Yeah, if I'm remembering my lunar geology correctly, that is. All right, let's see. Where's another place we want to go check out? Let's go ahead and switch our map back out to a zoomed out view here. Actually, let's just go all the way over to it. Ooh, we should go visit some of these highlands down to the south. We got some really good crater detail we can go check out there. Okay, let's go ahead and plot back over here. I meant to go here first. We can actually see what our full sky view is. Again, because we are dealing with actually not the best seeing conditions tonight, that's why we have a little bit of extra blur in these images. It is a little bit wavy up there. When you see that sort of waviness in the images, that is referred to as scintillation. It is due to atmospheric distortion. It's the same thing that actually drives the twinkling of stars in the sky when you're looking up there. All right, that's looking good right there. So yeah, let's go ahead and head down to the southern regions of the Terminator. This is the dividing line between day and night. Here is a good area to spot good crater detail. So we're going to head down there in our big telescope view here. So we're right on the Terminator now, so we should just be able to move south, which in this current orientation of the D-rotator and everything is to the right. All right, there we go, passing past more of those seas. Oh, wrong way. This way, there we go. Yeah, there's some good crater detail. You can see some more of those craters, some of which have central peaks, some of which don't. Where and when would be the best place to go in the desert to see a sky full of stars? Well, so we just passed first quarter, and so if we actually look back at this setup here, the best time in general to be looking for a sky full of stars is to be heading towards, well, not in this time frame roughly is the most difficult time frame to be spotting your good clear skies. And if you're going to be up if you're going to be up late, yeah, you'll want to wait till after that. So ignore all of these times if you want a sky full of stars. A waxing crescent time frame, the moon will set early, and so if you stay up reasonably late, you'll be fine. If you're going to be up past midnight for stargazing, the last quarter moon will start getting in the way of that. But in general, anytime outside of the first quarter to a full moon, if the moon is out of your way, that is going to be the best time frame to be looking up at the night sky. As far as where, well, there are actually a number of good places out here in the valley. Let me go ahead and get those marks off of here. And actually what I'm going to do to point out some things is we're going to head over to our NASA World view once again. And in this view, let's get back to where we are. Rancho Mirage is marked right on the, or rather the observatory is marked right on the center of the map here. And let's go ahead and move our thing to around here. Time frame so we get a little bit more detail. All right, so great places to go look up at the night sky. Well, of course, heading over to Joshua Tree is always good. Joshua Tree is over in this region over here. It's always great to go there. It's a bit more of a drive. If you aren't willing to drive that far, well, then there are some closer places. But again, if you want really good skies, highly recommend there. Again, all the way out past, let's see, I want to say actually Desert Center is around here. Yeah, Desert Center's around there. One of my favorite places, though you have to be careful about the time frame you go there because of the way certain insects might be problematic. Again, just don't go in monsoon season and you'll probably be fine. But it's Corn Springs, which is out past Desert Center. You go off the road down into a nice canyon over here. I love Corn Springs. It is nice and dark there. But again, it's like an hour and a half to get out there. Here, closer to home, there are a few good places. You can actually head out to the Thousand Palms Nature Preserve off the north side of the desert cities off in this area. You can head out to Sky Valley, which is up north here. You can even head down south as well. Down out of the 74 is a great place. You can head up towards the mountains in the 74. It'll head up this way around towards Sugarloaf. There's some good campsites right there that have some decently dark skies. Highly recommend that spot as well. If you're looking for a more destination stargazing experience, I'd recommend heading down to Borrego Springs, which is quite a ways around the bend, as it were. You got to make your way around the Santa Rosa Mountains down into this area down here, I believe. But yeah, Borrego Springs is beautiful. Highly recommend there as well. So I think that covered a good number of the places I would recommend for that. But yeah, there's a lot of good places is the key takeaway there. Just head away from lights and you'll find somewhere that's pretty good for looking up. And just make sure the moon's not going to be in your way and that the sky is clear. That's really all you need to worry about for getting good skies out here. All right, back over here. We have some great views at the moment. We got about 15 minutes left before we're going to be wrapping up. But we covered just about everything on the packet that we wanted to. Lauren, is there anything else you feel I should go over? Getting a no from Lauren. Okay, cool. So that means we get to do the bonus material right now, which the bonus material is we get to wander off away from the moon to more distant targets. Because as you might recall, when looking back at Stellarium, there's a couple of planets up near the moon in the sky right now. Again, this is today. So just north of the moon is Saturn. So why don't we go ahead and swing on over there? So let's go ahead and switch this view back here. And I'm going to move the telescope. So I'll be right back. Happens when you have headphones with cords. I'll be right back. All right, I'm back. As you can see, we got Saturn hanging out just in the edge of the field of view there. Let's go ahead and move it the wrong way. There it is. Get that up here. All right. Saturn is, of course, the second largest planet in the solar system. It is always a fun one to see, and with this view, you can definitely see a lot of that atmospheric scintillation, since we can't see a lot of good fine detail on or at Saturn right now. When we get those nice clear frames, though, you can see quite readily some of the gaps in the ring, or in between the ring and the planet. Let's see, I'm actually going to decrease our exposure time, try and get a really fast image. We're just going to crank up that gain, see if we can't get anything a little more clear there. There we are. Yeah, now you can see a bit more of those little details with the shadow of the rings falling on the planet right in this area here. Let's see. We can also be sneaky and use this software to zoom in even more and make it bigger. It's not bigger. That's just a lot of red. That's bigger. There's all that atmospheric distortion. All right. So now you can see a good amount of detail with that. And with those rings, it's always worth understanding the scale of them. Again, while they are very broad and easy to spot, as bright on this view as the planet almost, they are actually incredibly thin. The actual thickness of the rings, not the inner diameter to outer diameter, but rather the top to the bottom passing through them as though they were a plate passing through the plate, as it were. That thickness is on the scale of around 10 to 20 meters in most places. There are some areas where there are some towering spires that go up a few kilometers in thickness, but by and large, it's incredibly thin. But because it's made up of a lot of ice particles that are very reflective, it ends up being so bright and easy to spot here. There's a lot of material there, and it looks great. Let's go ahead and see, though, if we go ahead and zoom back out, if I can actually see the buttons I'm trying to push. They are very small on my screen right now. That wasn't the button I wanted. Also not the button I wanted. Oh dear. Just a second. Now I can see the buttons I'm pushing. All right. Cool. Yeah, I don't want to bend that. No, thank you. That one did the right thing, and now we want that button. There, we're back. Okay. Another crisis averted. Okay. Anyway, looking at Saturn right now, let's go ahead and increase our exposure time again. I want to see some moons. Moons take a bit of effort to see. We're going to need to increase our exposure time even more than that. Go ahead and hit this button here. And now we can increase our exposure time a lot. Let's go ahead and get way too bright here. No, I was expecting to see some good, easy to spot moons, but no, it doesn't want to show up. All right, well, maybe our skies aren't actually cooperating with us well enough tonight to spot these guys. Let's see. Go ahead and crank this one way. Ah! Oh dear, I went too far. Apologies. There's some moons. Yeah, we are dealing with a little bit of blurriness from the atmosphere. That's really making it hard there. I wonder if we can actually do something about that. Let's see. Gonna need to do a few other things to get there, but we've got only so much time. Let's see. So what are we seeing there? Let's jump over here and actually zoom in on Saturn to actually find out what we're looking at. Whoop. All right, we zoom in here. We should have Titan below the to the south of Saturn. We've got Enceladus and Tethys to the right, Rhea and Dione there. And again, keep in mind the telescope likes to rotate the camera, so this image will not line up perfectly, but it's actually not too bad. Let's see. Back over here. There we are. As you can see, it's rotated quite a bit. We actually have Titan hanging out up here, and we had Enceladus and Tethys here, and Rhea, I believe it was there. Is that correct? Jump back over. Yeah, Rhea is up on top, and Dione is off to the left. Dione is the one hanging out down here. So we were actually able to spot these moons. Again, that scintillation is giving us all kinds of problems up there. That's why I have that little disclaimer down at the bottom. But in any case, Saturn is great, but there is a bigger planet we can go to before we wrap things up. The actual first other place where we found moons, to tie it all back to the moon here. All right, so I'll be right back as we move on over there. All right, so we should be over near Jupiter, and I think I see some things in there. Just need to turn that gain back up. Oop. There's some scintillating stars if I ever did see them. Let's see. Should be over here. Where are we looking? I'm thinking we probably want to follow those. There it is. All right. Need to adjust the pointing on this telescope, it seems. So, towards, nope, the other way. How'd I know which way to go? Well, I was following those dots, because those dots will be the Galilean moons. The dots you saw up here, and again, I can actually make those easier to spot by increasing that exposure time. There's one. Now, let's see. Let's go ahead and figure out which one's which. It's a lot easier to figure out which one's which when looking at Jupiter than at Saturn, because when you look at Jupiter, when you look at Saturn as shown here, Saturn, that view, Saturn has seasons the way we do. That is, its axis is tilted, and right now we can see the rings orbit right over the equator, and because its axis is tilted and its main moons are pretty close to its equator, they could be spread all around it. Jupiter, on the other hand, has very little axial tilt, and as such, we always look right towards the equator of Jupiter when we are looking at it. So let's zoom all the way out, zip over to Jupiter here, and zoom in there. And as such, those moons tend to be very close to being in a nice straight line. And so Io is the closest, Ganymede is further away on the right, and then Europa further away on the left, with Callisto further out. The actual order of closest to furthest moon from Jupiter is Io is the closest, then Europa, then Ganymede, then Callisto. Hence why the little extra designations you have here, you have J1, 2, 3, and 4. These are the moons that Galileo discovered, the first moons other than the moon of the Earth ever discovered, and they were crucial in actually understanding that the Earth did indeed revolve around the sun, because it was thought that at the time by many that that everything in the universe revolved around the Earth. And so when these moons were spotted revolving around something not the Earth, kind of makes it hard to argue that everything revolves around the Earth when these four are not. So yeah, good direct observation. That was very important. Now, okay, so back over here, if we are looking, that object right up there is likely Io, and I have had about enough of this. Let's see if maybe we can actually adjust that focus a little. Let's just see if we can. I want to see if I can get a better point source for that there. Okay. Wants to fight me here. There we go. There we go. Let's see what we can do here. All right. Do-do-do. This computer's doing a lot. Really taxing it a bunch. Okay, so while we wait for that to go, maybe, or maybe it's there. It'd be great if it was there. Yes, I believe that's Io we're looking at right now, because again, the telescope likes to rotate things. Oh, cool, that did not end up connecting the way I wanted it to. Let's try that again. All right. While I continue to do that, let's just try moving this way here, which should take us, nope, not that way. Up, please. There we go. Over here, we should have Europa and Callisto next to it. Yep. There we go. Europa being the one above the, this one being Europa, that one being Callisto. A lot easier to just point. And again, if we pan back over this way, we've got Jupiter there and Io next to it, and Ganymede should be right there. Ganymede is always worth taking a look at because it is the largest moon in the solar system. It is actually larger than the planet Mercury, and that fact alone makes it quite a worthwhile place to actually go and see. We will be getting better views of some of these objects before too long. There are a number of missions heading out this way. There is the Europa Clipper mission, which, as its name suggests, says it's going to Europa. But then there is the European Space Agency's JUICE mission, which is the Jupiter Icy Moons Explorer. Yes, acronyms, fun. But yeah, that one will be visiting a number of these objects, doing various flybys and whatnot. But yeah, let's see if this thing will cooperate this time. Got a few minutes left before we're going to wrap up, and I want to get a good view of Jupiter. Okay, that's not going to cooperate, so we're just going to deal with the scintillation and just trust that this is about the best focus I will be able to get, unfortunately. I wonder if I could get better tonight. I might be able to, but we're close. So where we're at here, let's go ahead and adjust that exposure. Drop the gain. Well, actually, let's drop the exposure time first. Take that way down. And jump this over to this button. Now I can take it down even further. Drop it down to around there. And now let's really drop that gain. There we go. There's some stripes. And as usual, oh, wait. Well, maybe. Let's see. A little hard to tell. Let's go ahead and actually see if we can do some fancy tricks here. We're going to try some live stacking. Always risky to try, but we're going to try it. All right. That was more stacks than I want at that gain, so let's just turn that gain down. Turn it down even more. Down the exposure. Oh, there we are. Yeah, so that is 5 images being stacked together all at once. And so now what I'd like to do is just take a nice snag of that right there. And then we want to hit this button for a good big view. It's hard to say whether or not that's the red spot. We have, again, not the best viewing tonight. It was worth a shot to try. All right, so that was fun to mess with, the live stacking. Where is the option I'm looking for? This option. Go ahead and turn off that live stacking. Where'd it go? It's there. It's just a lot dimmer now. Go ahead and bring up that exposure or that gain. Yeah, I don't think we have the great red spot there. We can look it up, but honestly, it's always more fun to just find out, in my opinion. One of the fun bits with astronomy. Anyway, we've looked at a number of things here tonight. So let's go ahead and actually jump back over to this view here so we can look at all the different things going on here, and want to go ahead at this point and say thank you everyone for being here. Hope you've had a wonderful time. If there aren't any last minute questions, just want to say, yeah, hope you guys have had a wonderful time here, and we wish you all the best this October as we head into the last bit of 2021. And also definitely go and pick up one of these packets so you can do some observing on Saturday, because that moon up there is going to be looking a little bit different. It'll be in a little bit different spot, and that's always worth seeing all the different things going on in the sky, especially when it's so easy to spot by taking a nice good look at the moon. So again, thank you all for being here. We hope you've had a wonderful time, and we hope to see you again soon. Also, a special thank you to the Rancho Mirage Library and Observatory Foundation, who makes programs like these possible. And finally, thank you to Ron Treat, our docent, and any other docents I might not have seen in the chat yet, because I haven't been looking explicitly at it. And also, thank you to Lauren Zuckerberg, our observatory program coordinator. Again, have a wonderful night, everyone. We'll see you again soon.